Sue is covering cation and anion, is it?
Yeah. I don't understand anything.
Aiyo. Okay. I'll try to explain to the best of my effort. Okay. What happened is that school is currently covering something called qualitative analysis. Did they use this word?
Nope.
Then how do they intro the topic?
Cation.
Okay, tell me more about this cation and anion thing.
She just said that and then she went through the lesson.
Okay, give me more to work with. Random things that she says.
The things that she says.
Yeah, whatever's related to cation. Is it different colors, different precipitates? Is it?
Yeah, that.
Okay. So the topic she's currently teaching is called qualitative analysis. In total, right, there's actually 3 parts to it. The first part is what you said already, cation. The second part is anion. Actually, there's actually a third part called gas test. So there's cation test, there's anion test, and then there's gas test in total. Okay?
Yes.
So in this case, right? Okay, let me explain to you what this chapter is about in general. Okay. Can you imagine that there's someone dead? I don't know why the person left bones, but yeah, someone's dead. And the person, then it's like some piece of glass was found, and then he drank something and he died. So the police people, the popo, basically take the sample of fluid, and now you're supposed to test this thing to find out what it is, whether what he vomit or what he drank to cause him to die, or is it related to him dying. Qualitative analysis is exactly this. You're a detective. They're trying to basically find out what is this mysterious things that is collected from the crime scene. Then, of course, since we are still in O levels, they simplify the situation. In real life, it's a lot more complicated. In this, they assume that this is whatever's collected here will always be a salt. What's a salt? A salt is the same as the word ionic. What's an ionic compound?
Metal plus non-metal.
Good. Very good. That was the direction I'm heading to. So, any salts or any ionic compound will definitely have a metal and a component of non-metal. Okay, so there's a non-metal and then there is a metal. In this case, metal is what forms the cation, and the non-metal is what we form the anion. When by doing the cation test, we will discover half of the puzzle piece, and then do anion, we discover the other half of the puzzle pieces. That's what qualitative analysis is. You are literally the police officer trying to find out what mysterious liquid find during the crime. And it comes with the metal and the non-metal part to piece together to find out the actual chemicals that's been found. So far, so good?
Yes.
Very good. So every time when you think qualitative analysis, they're trying to get you to do tests and observe outcomes to then have the identity of something. That's what it is. So, there is good news and there is bad news. Bad news in cation test, you have a table. There is quite a bit, in fact, maybe 1, 2, 3, 4, 5, 6, 7, 8. There's 8 of them to remember. That's the bad news. Good news, there is shortcuts or easy way for us to find certain patterns to remember them.
Oh, okay.
So, okay. Why is it simple? Okay. So what happened is, okay, let's do the cation. So how do we do cation tests? Okay, so what did school mention about cation tests? Like they just give you the table. They tell you that in actual real world, how do we do cation tests? You basically in the lab, correct? How do you do cation tests?
Got the equals something equals something.
Bro, you it's like the 有一个人他打我，他谁？那个有一个头两个脚，It's like why everyone also 一个头两个脚。Okay, equal something equal. Okay. What you say is true. Cation test, according to your O levels, there are two chemicals used to test. The first chemical used is basically equals sodium hydroxide. The second chemical that can also be used is equals ammonia. Equals ammonia also has another name because when we take ammonia, NH3, when you dissolve in water, the outcome that it forms becomes NH4OH. This is actually ammonium hydroxide. So, aqueous ammonia identity is ammonium hydroxide. I want you to pay attention to the word hydroxide. Both outcomes contains hydroxides, and later on we will make good use of it. So cation test has always two stages. Stage number one, we focus on the drip. We only not like when Nike Adidas drip, not that drip, not the Supreme drip, but rather you take a dripper and you drip into your sample. Why do we drip? In this case, we either drip NaOH or we drip NH4OH, which is what was mentioned above, right?
Yes.
So why do you drip the chemicals inside? The reason is to check whether is basically if PPT forms and what is the color of PPT. So this is the reason. You are trying to check if you know what PPT is, right?
Precipitate.
Correct, precipitate. So precipitate is anything that is insoluble. Basically, it's an insoluble chemical. So number one, we basically focus on things we drip, just basically a few drops, and see, in this case, does the PPT form. Let's say the PPT form. Then what color is it? Oh, okay, then it's like brown or it's like orange. You're trying to find if PPT forms, did it form, and the color. Then you go to the second step. You pour the chemicals in. Pour in chemicals according to a textbook is called add in excess. So basically, now you take the same cup. In the beginning, the cup inside got PPT already. So just now you drip. Now you take the whole beaker and then you pour all the chemical inside. So you add in excess, like as if it's like a buffet. It goes half free. Just pour everything inside. So why do you do the second step? Is to check if PPT dissolve or not. Basically, you can only have two outcomes. One, the PPT becomes soluble in excess. 2. The PPT becomes insoluble in excess. So later on when we do the notes, right, I'm not gonna like write a lot of words. I'm going to focus on two things: color of the precipitate forms. 2. When it's added in excess, is it soluble or not? Because that's what we do anion tests. You always do the dripping to see PPT forms, and then you pour, add in excess, and see whether it's soluble.
Okay.
Okay, good. So this is the cation test table. So under the cation test table, the simplified method is to group things with group PPT with the similarities together. What do I mean that? The first one is basically all the colored PPT. The second group is all the one with white PPT. And the very last group is anything with the no PPT. It means don't have PPT form. Okay, so the first, we are building a table. The first one is cation, and the second one is basically tested with NaOH, sodium hydroxide. And of course, the third one is being tested with aqueous ammonia, which is NH4OH, aqueous ammonia. The first one, things that are colored, refers to copper 2+, iron 2+, and iron 3+. In terms of name, they call this copper 2. The 2 refers to the charge. This one, of course, is called iron 2. And this is called iron 3. So, they have unique colors. That's why they are grouped under the colored PPT. Copper forms blue PPT. So you write the word blue because it does PPT forms. Iron forms green PPT. And iron 3 forms brown PPT. So this one is basically the outcome of the first stage of the test. When chemicals are dripped inside, what color PPT forms? Now we're going to lead on to the second stage. It will be when it's poured in, added in excess, what happens? The first one is insoluble, insoluble. The only odd one out is this corner. So rather than memorize the whole thing, in study method, this called strategy is called chunking, where you chunk a bunch of things together. They are all color. Copper is blue, iron 2 is green, iron 3 is brown, and then everything is insoluble except that one corner. It helps you to remember things rather than 1, 2, 3, 4, 5, 6 combinations. You combine them and then you have less things to remember. Then you can figure out the whole thing together. It is something that will help you not help you, just help everyone actually to learn and remember easier with less effort and remember equal amount of things. So the first one is called the colored PPT group. Okay, all good?
Yes.
Okay. I will encourage you to write this down, at least this piece of paper. Later on, we'll be practicing questions. And the questions having this will make it a lot easier to learn. Okay, then the second thing will be related to all the white PPT. You remember, okay, this one is zinc, aluminium, lead, Z. So zinc, aluminium, and lead. Then the odd one out, the outcast, the one that being pushed out the corner to bully is calcium. Later you see why they put as a different. As I already mentioned, all of them are white PPT, so I don't even have to remember everything, just white. Everything just write the white PPT. Right? There's no such thing as a white pen, so I'm writing in grey. So all the PPT forms. The only odd one out is this corner. This one will have no PPT forms, which this one overlap with the very last group, the no PPT.
Okay.
The unique thing under this group lies in its pattern. This is soluble, 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 soluble. Only this one little corner has. Okay, maybe I use another. Sure. Okay, insoluble, insoluble. Whereas calcium is the only odd one out of being insoluble in the first column. So this is the odd one out, this is the odd one out, this is the odd one out. And that ends the second group. And last but not least, you just have one more, which is NH4+, which is this is ammonium ions. In this case, it totally has no PPT form at all. In this case, it will just be no PPT. But then what form? In this case is ammonia gas forms. And in this case, we'll have no reaction. Why? Because you can't have ammonium reacts with ammonium. Because they are the same. Ammonium is the same as ammonium. So no reaction will be observed at all. And that covers the third group. So, colored group, the one with white PPT, the one with no PPT. So the last two group overlaps on calcium. That's all the PPT you need to know.
Okay.
Does your school teach it this way? Or they should give you notes?
They gave us notes. We have notes, and then we have like this piece of paper in the file, like with all the things that we need to know.
Do they arrange it in a way and tell you like strategies to remember it, or just like, oh, this one you need to know?
Just the things that we need to know.
Yeah, but this one will be very soul crushing, and you see the whole list is like so many things. So okay. So that's cat ion is done already. No more. Oh, one more thing to think. All PPT form cation tests are hydroxides. So what does this mean? That means this is copper hydroxide, iron 2 hydroxide, iron 3 hydroxide, zinc hydroxide, aluminum hydroxide, lead hydroxide, and so on. They are all hydroxides. Okay. Nice. Okay. Now we have the anion table. Okay. So basically, this is the anion test. Remember, in the very beginning, we are trying to find out what's the mysterious chemicals. We know the metal part through cation test. Now we have the anion test side of things. Okay. When it comes to anion test, it's a little bit headache because there's no simplified way to remember. However, there is ways to simplify the words. So in general, there are key method for us to remember. Okay. Okay, let's give this a try. So the first column is basically what the different anion. Okay, I want to introduce this as the first one because it's something special. It comes out in the exams and they kill students all the time. It's basically the nitrate ion. So for the anion, so what are the tests? How do we test nitrate ion? So we add sodium hydroxide plus aluminum. It could be aluminium foil, it could be aluminium powder, it could be aluminium. You just add aluminium. And then we have the observation. What observation will you see? You will have ammonia gas form. Why do I put this right in the first place? I want to introduce this, you see. In this case, we use sodium hydroxide, right?
Yes.
We add to the ammonium ions, right? Ammonium ions. Then ammonia gas forms. So NaOH causes ammonia gas forms. NaOH causes ammonia gas forms. Wouldn't it be exactly the same? Then how would I know whether is it an ammonium ion or is it a nitrate ion? The key difference lies in this. Aluminium. If aluminium is added, then ammonia gas is formed. It's nitrate ion. However, if aluminium no need to add, only NaOH only, aluminium don't even have to enter the system, and then ammonia gas immediately form, then it's ammonium. That's how you tell the difference.
Okay.
Okay, that's why later on when we try questions, you will see such things comes up. Later you will see. Okay, so the next one is basically carbonate. This is carbonate. Any idea when carbonate added with acid, what happened?
Carbon dioxide.
Yeah, very good. So in other words, the test is basically we add acids, and all carbonates give you carbon dioxide gas forms. Okay?
Yes.
Yeah, so knowing that makes it super easy to remember. Okay, the third one is basically the I, and this is basically the iodide ions. Okay. Iodide ion has a very special color. It's yellow. Yellow is the key color of it. So how do we do this? How do we test? We add lead to nitrate. So PbNO3. So what will happen is you will form yellow precipitate will form. So yellow precipitate will form. What's the identity of the yellow precipitate? Is lead iodide. Lead to iodide. Okay, so lead iodide. So whenever they give you yellow PPT, just remember in this case, right? Iodide and lead are good friends. Iodide and lead are good friends. When I ask you lead and give you yellow PPT, then iodide exists. The opposite is true. They give you iodide and then it forms yellow PPT, means lead exists. So lead and iodide are good friends, these two keywords. Next, we have something called chlorine. So basically your chloride ions. Chloride and so you basically add silver nitrate. In this case, chlorine and silver are good friends. I'm teaching you all the keyword triggers. That means when you have lead, it relates to iodide very often in exams. If you have silver, it relates very often with chlorine. Why? Because they form white PPT. They're insoluble. So white PPT forms. And then, in this case, it will form AgCl, which is also called silver chloride. And last but not least, you get your SO42 minus, which is your sulfate ion. In this case, you add barium nitrate. Okay, so in this case, what I observe is also white PPT. White PPT formed to be barium sulfate. Okay, all good? Yes. So the list is a lot shorter than your cation, but your cation can be put into 3 categories to simplify with the memory. Okay, then the very last one, right, is what we call a gas table. Technically, you already remembered half the table from different parts of the formula of the syllabus. So it's called gas table, gas test. It's how you test different types of gas. The first one is called ammonia gas. How do you test ammonia gas?
Ammonia. Litmus paper.
Very good. Okay, test with moist. Either you use the word moist or use the word damp. Red litmus paper. ammonia gas, right, is the only alkaline gas you study in your O-level syllabus. Only alkaline gas in O-level syllabus. So therefore, if you have your red litmus paper, then what happened would be the red litmus paper turns blue. Okay. Then you have your so that's your first guess. Then the second one would be carbon dioxide. Okay, for carbon dioxide, it's very easy. You test with
lime water.
Yeah. Okay. Here comes the additional question. What is lime water in terms of chemical equation? Chemical formula. Okay. Lime water is calcium hydroxide. In O levels, there are chances that it's asking you what lime water is. So it's calcium hydroxide. So when lime water is tested with carbon dioxide, it will form white PPT. So white PPT will form. In this case, the chemical reaction is actually lime water reacting with carbon dioxide. It forms calcium carbonate, which is plus H2. This is the white PPT. This is a acidic oxide. The carbon dioxide is an acidic oxide, and this is actually your lime water.
Okay.
Followed by that, we have our chlorine gas with Cl2. So how do we? What's so unique about chlorine gas? Any idea?
No.
It can bleach things. You know what bleach is?
Yes.
Okay, people say, hey, the person dead already. Oh no, it's like, oh no, I killed someone. Can you help me? It's like, we need to go buy bleach. So what happens is that bleach will help you to like clean up blood stains. Because all the blood stains after you pour bleach, you get bleach and get fade away. Then normally even like normal colors, like all the color pens and stuff, you pour bleach, it has the ability to make it turn white. So in one day, assume you have to clean up a dead body. I don't know where the dead body comes from. Buy bleach. So yes. So test chlorine gas. This test with litmus paper. You realize that I on purpose didn't say what color litmus paper because both litmus paper can get bleached by chlorine gas. The first one is the blue litmus paper. And then it will turn red. Why? Because chlorine gas is an acidic gas. Then after that, it goes bleach, which turns white. Then you have your red litmus paper. Red litmus paper, because it's an acidic gas, right? I mean, this one turns red. And this is a blue litmus paper, right? But in this case, if this is a red litmus paper, nothing will change. It will stay red. So it will remain red. Okay, and then finally it will be bleach. course, you have your hydrogen gas. How do you test for hydrogen gas? This one from other chapter as well.
Lighted splinter.
Yes. So test with lighted splint. Then after that, what will test with lighted splint? Then what will observe?
Gas involved were. Wait, I know.
Okay, wait. Give chance.
Extinguish lighted splinter with a pop sound.
Yeah, very good. So it would extinguish with a pop sound. Yes. So lighted splint in this case, this is a lighted splint, means got fire. Then what happened? The fire will disappear, and then you'll have a very loud pop. Okay, good. Then its sibling called oxygen gas. How do you test for oxygen gas?
Glowing splint.
Very good. What's so different between lighted splint and glowing splint?
One's lighted.
Oi, you. Okay. Glowing just means that it's like cigarettes lah. Got fire, but you can see like cigarettes or incense. You can see the fire, but it didn't have didn't have the flame. It only got just the light. Then what happened after that?
Gas involved really likes glowing splint.
Yeah, then the fire go whoa, come back. So in this case, we will say glowing splint relights. Yeah. Okay. The very last one, right, also overlaps with another chapter called redox reaction. Means oxidation and reduction. One of the things, right, I was told that they remove it from practical, but I'm going to just include it for completion's sake, okay? Because I was told that the chemicals was like hazardous to the students, so they stopped allowing students to use during practical. But there was a debate whether that should be removed or not removed in the syllabus, but I don't know. I'm just going to give you. So this one will be sulfur dioxide. SO2. Okay. So how do you test for sulfur dioxide? The first way to test for it is use acidify, means that it's mixed with acid. So acidify potassium manganate. So this one has the keyword manganate. Okay, then there's the second one. If you compare, this is called acidified, also potassium dichromate. In this case, for manganate, is mobile phone charger, MPC. Mobile phone charger. It stands for manganate will change from purple to colorless. Whereas for dichromate, it becomes DOG. D-O-G. DOG. It refers to dichromate when reacted with sulfur dioxide, when it touches sulfur dioxide, when you test with it, it touches it, you change from orange to green. That's sulfur dioxide. And later on this chapter will also carry this knowledge you learn here will directly be copied and used under a chapter called Oxidation and Reduction. And redox, oxidation and reduction. So knowing it here allows you to save the effort. That means remember one place one time, but apply to 2 chapters. But don't worry about it. If you forget, right, it's my responsibility to remind you. Later on, when you're not sure about this one, you forget, just ask me. Then we will just try questions and get familiarized again when the time comes.
Yes.
Okay, then I'm gonna give you questions. Everything's under qualitative analysis. Literally, the question given to you now is like throwing you straight into the sea. If you drown, please say, then we can do it together.
Okay.
Okay, they are all school questions, so I'm gonna try. Qualitative analysis. Okay, the link is sent to you. Okay, so let's try this. Okay, so for question 1, the first thing that directly jumps at me, I see aluminium foil. What should that tell you about it?
Nitric ion.
Correct. So, okay, which solution would produce gas from both sodium carbonate with excess sodium hydroxide by aluminium foil? So, in this case, answer must have a nitrate, make sense? Because got aluminium. But at the same time, this thing must form a gas with sodium carbonate. So anything reacts with carbonate 90% of the time is an acid.
Nitric acid.
Yeah, agree?
D.
Huh? Bro. I'm gonna strangle you. You tell me nitric acid, then you pick D. Okay, what is D?
It's the wrong one.
Yeah lah, but what's the identity? You also learn from it, ma. So what is NH4NO3? What's the name of it?
Ammonium nitrate.
Correct, it's ammonium nitrate. Okay. Since give chance. You Okay, I reset. I abuse moderator power already. Okay, reset. Nothing happened, right? Yeah. So what's the answer?
A.
Yeah, whoa, good job. You said nitric acid, then the D lights up like, what is this? Okay, question 2. So whenever we see yellow precipitate, what is it related to?
Iodide.
Yeah. Then you need to figure out with aqueous ammonia, and then it's dark blue solution. So what ions uses the color blue?
Blue.
All the blue most of the time.
Copper.
Yeah.
Copper iodide.
Yes, agree.
Yes.
So if the moment you know what you're dealing with, right, it's actually quite easy. Okay, question 3. Soluble in excess. So white. So it should be zinc, aluminium, lead, and calcium, one of them. But then, okay, this one you can refer to your notes. I leave it to you. Totally confusion. We can do it.
Lead.
In insoluble. True. Answer can either be aluminium or lead. So agree. A small piece of sodium. Okay, question 4 is a little bit more tricky. So there's layers to it, okay? So what happened is that, okay, first of all, when you have sodium and you touches water, what happened?
Vigorous reaction.
So then what forms?
Hydrogen.
Agree? So you form sodium hydroxide and hydrogen. So in this, right, they hide the information. They give you sodium, touches aqueous. Aqueous means got water, right? So it will form sodium hydroxide. Then sodium hydroxide reacts with copper. Then what will happen? Blue precipitate will form. Then you have to ask yourself, in the end, when the blue precipitate form, is it soluble in excess? Because we apparently add so much and it's excess now.
No. Insoluble.
Yes. Okay. So which one is not observed during the reaction?
C.
Hey, what? No. Sodium burns with a yellow flame because it reacts vigorously. So you burn and then you fly around on the surface. So both CD happens. We're looking for not observed.
BB.
So basically it cannot dissolve, so blue solution will never form. Question 5 is my system point this is a tier 3 question. Meaning 99% of students got it wrong on the first try. You want to do?
It's like so hard.
It's tough. Okay, we do this together, okay? Okay. You see the graph? What things okay, so whenever something reacts with acid, what things reacts with acid? Nitrate, sulfate, carbonate, what things reacts with acid all the time?
Metal.
Okay, but in this case, if it but we don't have metal here. About the anions, what other things also reacts with the acid all the time? Start with C. Yeah, carbonate. So in this case, it says, what did it say here? It says addition of dilute acid. So that means the acid is added, then some of the PPT reacted, and then it drops down. But it didn't drop all the way down to 0. Some of them remain the same. So can we agree that some of them react with acid, some of them did not, right?
Yes.
Okay. So here says addition of reagent M. That means when you add reagent M is gradually added to solution N. So when M plus N, you got precipitate. So there is 2 precipitate here. One of the precipitate highly likely be something carbonate because it can react with acid. Make sense? The other one is just a PPT, but we also don't know what it is. So out of A, B, C, D, A is out already. Why? Try to think. If not sure, okay, then let's go through. Why is A not possible to be answered?
Because
Something to do with this dotted line that we drew. If all of them are carbonates, then all the acid inside, then what will happen to all the precipitate? crash all the way to become 0, right?
Oh.
But did it become 0? No, it's not 0. So it cannot just be carbonate only. Make sense?
Yes.
Okay. So now this one is to test your how much you remember about something soluble or not. So in this case, this one got barium carbonate, barium chloride. Is it both insoluble?
Barium.
So you got barium chloride and barium carbonate. Is it both insoluble?
Yes.
No. Barium carbonate is insoluble. Barium chloride is soluble. Question: are you good with solubility table?
That one
Okay. Can. Then I help you. Okay, so after this, maybe we'll spend some time to do about solubility. Okay. So this one will be. Okay, so let's do this the opposite way. I think the answer is D for dog. So, why though? You form barium sulfate. You form barium carbonate. Both of them is insoluble, the PPT. So at this stage, here will form barium carbonate and barium sulfate. Then after we pour the acid, what happened? What will react?
carbonate.
All the carbonate will be removed, but this one remains unreacted. So what stays? Here? Will be the barium sulfate. So that proves that the question answer will be D for dog.
D for dog.
Yes, because it requires you to understand qualitative analysis, how something react. It also you need to understand about solubility, but we will cover solubility later. Okay? Nice. Okay, question 6. Try. This one is different. Now you're the government. You suspect the fertilizer got poison. You're trying to test what's inside the fertilizer. The dirty green precipitate. So what does that tell you?
Iron 2.
Good. And then when you warm the mixture, red litmus paper turns blue. What gas is it?
Ammonia gas.
And in this case, got aluminium. Don't have aluminium.
B.
Trust yourself. Okay. Yeah, you see correct. Why? Question 7. The equation shows you what gas will form, okay? something to do with the diffusion speed though. How do you decide whether something diffuse fast or slow?
Fast or slow?
So the gas will diffuse at different speed. Do you know how to decide which gas diffuse fast, which gas diffuse slow?
I don't know.
Okay. So I ask you, if compared to a really thin guy and a sumo wrestler, who most likely runs faster?
Thin.
Yeah, the very thin guy. So in this case, you measure how heavy the gas are by calculating the mass number. So you have NH3 ammonia gas. You check the periodic table. This is 14, and hydrogen, and then there's 3 of them. So the mass of NH3 will be 17. And then you check your HCl. This is 1. This is 35.5. 36.5. So who do you think is heavier?
HCl.
And therefore, this also diffuse slower. This is lighter, this one diffuse faster. So, this one will make the red litmus paper turns blue, right?
Yes.
This one is HCl. Hydrochloric acid is an acidic gas. This will make the blue litmus paper become red. So which one will happen first? So red will turn blue before the blue turns to red again. Because this will arrive first. This will arrive second.
Okay.
So try. Piece everything together.
D.
Yeah, trust yourself. Yeah, D. 快点跟我讲，快点 confirm 是不是 correct? Just trust yourself, should be correct. Okay, question 8. Would not produce a precipitate. So it's with the chloride. Okay, rather than just give me the answer, you tell me which one cannot be the answer. That means which one will produce precipitate, so throw away. A?
Yes.
Why leh? Silver and chloride are best friends, right? They form precipitate. So just now we look. You see our notes. Silver and chloride are best friends. Lead and iodide are best friends. Oh, I forgot to write the last one. Barium and sulfates are best friends. Barium and sulfate, silver to chloride, lead to iodide. They are like couples. They all form insoluble PPT together.
Okay.
So going back to this question, yes. So the A will form precipitate, lead chloride. B will form precipitate. Sorry, A will form precipitate, silver chloride. B will form precipitate also, lead chloride. In terms of C, can PPT forms? This is a cation test. Check your tables.
My tables.
Your cation test table. This one.
No PPT.
For cation test, it will be no PPT form, right?
Yes.
So that most likely answer should be
C.
Good. Okay, question 9. If they say yellow PPT precipitate, what does it mean?
Die.
可以的，这个应该你可以做。Then green precipitate.
C.
No precipitate. No gas. Let me know if you need help. But this one is totally within your ability to do. But it's a bit tricky.
Quite wrong.
Okay. So you definitely figure out the iodide, right?
Yes.
Okay. Then why is it not ammonium? So we focus on this. No gas is formed when heated with sodium hydroxide. If the thing is ammonium, sodium hydroxide, pour inside, the ammonia gas come out already, right? So that's the reason. Make sense?
Yes.
Other than that, it's actually correct. Okay. Question 11. Try. This one, I want to highlight one thing. You see green precipitate?
Uh-huh.
Normally green precipitate, what is the ion?
Iron 2.
Then if green turns to yellow, and this yellow gives reddish brown, green can turn to reddish brown. This is iron 2. This is iron 3. The process is rusting. It oxidizes. It's possible. Iron 2 is very uniquely, if you keep it as it is, it rusts and reacts with oxygen. So the green turns to brown. Then be careful. This is the only time people get confused. It's like, J, 你不是讲那个 iodide should be iodide. It's like yellow. Yes, but in this case, yellow solution got 5% of the time, very small possibility, refers to iron 3 solution. Okay, so sometimes they on purpose they give you a certain solution is yellow in color, then when it's tested, then brown precipitate form. Then that thing confirmed not iodide already. You understand what I mean? Because iodide cannot give you brown precipitate. So 90% of the time, iodide is yellow. There's this 10% exception that yellow can also refers to iron 3, which they will always give you some other tips, some other observations, like tested and then reddish brown precipitate form, kind of situation. So in this case, at one glance, this is an iron 2 turned into iron 3 situation. Okay, so give it a try.
D.
Nice. Are you good with calculations?
I know how to do NA-mole concept.
Okay, I think NA-moles don't have concentration. I'll teach you briefly here first. Later on, when under the actual chapter of moles, I'll teach you proper, okay? Okay, so this one, what happened is concentration. Basically, concentration means how yummy our Milo or coffee tastes, right? More concentrated means less water. Less concentrated means more water, right? So concentration is measured with number of moles per volume. Means number of moles is like your coffee powder added how much water volume. This unit is in mole. volume is in dm cube, concentration is called moles per dm cube. So in this case, we see that the copper sulfate is so this is the volume, this is the concentration. So we take the volume times concentration, you get the mole. So in this case, volume is 4 cm cube. We have to divide 1000 to become dm cube because the answer, the thing has to be in dm. Multiply by 1 mole per dm cube. So if I press calculator, 4 divide 1000 times 1, then you get 0.004 moles per dm cube. Okay? Okay. Then at the back you have sodium carbonate, which is this. So get 8 cm, divide 1000 to become dm cube, multiply by, it's also 1, so no need to multiply. So should be same pattern, 0.008 mole per dm cube. So this is copper sulfate, and bottom one is sodium carbonate. What does a reaction vessel contains? So what happened is this one, they exchange boyfriend. Copper sulfate plus sodium carbonate. You go through precipitation. That means copper carbonate and sodium sulfate. They react this way. So you will form copper carbonate, which is insoluble, labeled with S, plus sodium sulfate, which is labeled with A cube. So in this case, we label the amount we calculate earlier on. This is 0.004. Actually, not moles per dm cube, it's just moles. So 0.004, this is 0.008 moles. Equation already balanced. So in this case, we call this limiting reactant. That means it's not enough because it's lesser, right? Limiting a reactant is like when you go through baking, then you basically run out of sugar. Then the amount of cakes you bake get limited by sugar because not enough sugar. Make sense?
Yes.
So this is limiting reactant. Reactant. This is what we call excess. Means got too much. So if this is excess, so in this case, this one will all be used up. This one bye-bye already. This is colorless. This is also colorless. And this will be a blue precipitate. In this case, what would be the answer given this is the analysis? Try to analyze and apply to question 12. So you are the detective, you are given this report. Who is the culprit? What is the outcome?
Something colorless.
This one no more. All reacted. So you will have blue precipitate stuck in first one colorless, second one colorless. So the solution is colorless, but the precipitate is blue. Oh, sorry. Because this is copper carbonate. This is a teal color, so sometimes they describe this with green as well.
Oh.
Which after this I need to give you a list.
Then D.
Okay, this is a good opportunity to bring up something. Copper, it's a because it gives you a lot of trouble. Copper metal is brown, and sometimes copper metal is described to be pink. Can I write this down? Yes. Because copper metal can be described with brown or pink. The metal. Then, most copper compound, mean copper something, are all either, most of them are blue precipitate or blue solution. Here comes the exception. Then we have copper carbonate. Copper carbonate tries to be funny and being a green thing. So can you understand that in this case, if you got too used to green must be iron too, this thing can kill you?
Yeah.
Yeah. So sometimes they tell you there's a green solution, then when tested with sodium hydroxide, it turns blue PPT. There must be copper instead. And then the very last part. The very last part is basically something called copper oxide. Copper oxide is black in color. Now you know why copper is a problem. The color keeps changing one. The good news is this is all there is. This is everything in the syllabus that I've seen before. If it's metal, that is brown or pink. If it's copper something, most of the time it's blue in color. That's the color related to it. Copper carbonate is the green one, and copper oxide is the black one. Write it down somewhere. This will save your life someday.
Yes.
Yeah. Okay, let me know when you're
Done.
Oh, that was fast. Okay, we do one more, then let's take a short break. Question 13. Aqueous ammonia is added to a chloride salt. White precipitate. So in this case, normally chloride, best friend with chloride should be silver. Too bad silver is not here. Then the other possibility would be
Lead.
Okay. Aqueous ammonia is added to a solution of chloride salt. So then white precipitate is formed, which dissolve in excess. So according to your yes, because only zinc can be dissolved in excess. In this case, it cannot be silver, it cannot be lead, because they will not form a solution. They will form a bunch of PPT. Make sense?
Yes.
Okay. So later come back, we'll actually do more questions related to anions as well as the gas tests. Just go, I don't know, drink water or toilet break. Use maybe about 3 minutes. We'll come back at 6:54. Just clear your head, chill out, then I'll just come back and continue. Okay? Okay, see you in 3 minutes, so 6:54. Hello.
No.
Okay. Guess. This is on guess already. Question 14. Let's try. What? Okay. Try.
Oh, what the hell?
This one will not change. Because carbon dioxide gas is an acidic gas. So it will change the blue litmus paper into red color, right? Yeah. So then the second one, which one will change the color though?
Chlorine,
Then the third one, which one will change color?
ammonia,
No, that's in the last one, the D.
hydrogen chloride.
Correct. Then D, why ammonia won't change the color? You say it will not change color. The answer is C. Hydrogen is neutral. Of course, it doesn't change anything. Why ammonia don't change anything?
Because ammonia is from red to blue.
So basically blue will stay blue, right?
Yes.
Okay, good. Question 15. White precipitate. Which reaction is white precipitate present when the reaction is complete? The keyword lies in adding all the excess. So B. Will there be white PPT?
No.
Because it will dissolve in excess, right? For aluminium. Then C. Is the PPT even white?
No.
Yeah, lor. So because we're looking for white PPT, so C cannot be. Then D. Is there any PPT that forms?
No.
Silver 跟什么是 best friend?
Silver and chloride.
Yeah. So they silver and chloride are best friends, so they will form acid. Form precipitate. I mean.
Okay.
Question 6. Look at your notes to refer if there's any need to.
Is it A?
Aluminium is colorless. Wouldn't number 3 be calcium instead? Because in sodium hydroxide, everything's soluble except calcium.
Oh yeah.
So
Answer is C.
huh? I thought number 3 is calcium.
Oh, number 3 is calcium.
Yeah, because you read vertically, ma. Number 3, when tested with sodium hydroxide, is white. There's calcium. Can be B, can be D. Then why not B?
Because
Because
aluminium in
aluminium in
sodium hydroxide is white color.
and soluble in excess. Because added soluble, then it will dissolve.
Yes.
Then in aqueous ammonia, adding excess will have white PPT.
Answer D.
Okay. Okay, I'm getting a bit confused. Okay, let me run through this. Because I think you said something that is correct, but the application is confusing.
This chapter is confusing.
I know. It's one of those chapters that that's why I started with the table. I said don't bother memorizing it, you'll get more confused. Just write down and refer. It's easier that way. Okay. We read vertical downwards.
Okay.
So the chapter 1 is Z, zinc, aluminium, lead. So zinc, aluminium, and lead, and then calcium. Soluble, 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 insoluble. Soluble, insoluble, insoluble, no reaction. So in this case, if I read this, adding excess then got white PPT. What should it be? So this one is NaOH. This one is aqueous ammonia. So in sodium hydroxide and then got white PPT, that means it's insoluble. So
Calcium.
yeah, because NaOH is the only insoluble, right? So this one should be calcium. Does it make sense?
Yeah.
Okay, so now if this one is sodium hydroxide, at first was colorless, but when it comes to ammonia, it's white PPT. So it should either be aluminium or lead, right?
Yes.
So but there's no lead to choose. So this one should be aluminium. In that case, our answer would be B, really, aluminium and calcium. If everything also soluble, then it's zinc. So what happened? What happened just now? What's with the confusion? I got confusion.
I actually don't know.
Okay. Okay lah, understand. Okay, try question 17. Okay, whenever they test something with the barium nitrate. Okay, so this one I need to update the notes earlier on, because just now is to go through the chapters. You know, this, and this, all these three of them. This one need to be acidified. Means you need to add acid. This one needs to acidify. And acidify. Why do you need acid? Why need to add acid? Acid is added to prevent carbonates from forming. Why? Because when you have acid will react all the carbonates away. Then you just become some sort of salts. So when you acidify, in this case, right, lead carbonate impossible to form, silver carbonate impossible to form, barium carbonate impossible to form. Because there's some say, how come we got carbonate form? Because there are a few ways of thinking about it. One, air got carbon dioxide, then you might react to form carbonate. Two, you don't want the precipitate to form, then you doubt whether is it a silver chloride or silver carbonate. So we make sure that we add acid inside to make sure carbonate will never be able to form inside. Question 17 is exactly asking you this. When you are trying to test barium nitrate with sulfate ion, you add acid to make sure carbonate will never be able to form. That's the answer why the acid was added.
C.
Yes. Question 18. Sodium hydroxide 5. Not in aqueous. Okay, what precipitate should be 5. Nice. I like how you last time. GG easy game. I don't even bother to ask. I know the answer. Good job. Both is carbonate, one is ammonium, one is sodium. So the main thing I think you can test for the ammonium.
I need help.
Okay, so in this case, both of them is carbonate. So testing carbonate cannot tell the difference, right?
Yes.
So now we got one is sodium, one is ammonium. According to your cation table, how do we test for ammonium?
Litmus paper.
No lah, that one ammonia gas, bro.
Ammonium?
Yeah, your last. Okay. Ammonium.
Yes.
How do we test for ammonium?
So, sodium hydroxide.
Correct. You take sodium hydroxide, bam, and then you see whether got ammonia gas comes out. So in this case, how do you test for? Make sure the ammonium is tested.
Testing aqueous sodium hydroxide and warming.
So you warm to make sure the reaction happens fast and all the ammonia gas comes out. Question 20.
Finish.
Yes. Okay. Submit. Okay. Okay. Really good. Pretty decent performance. That's good. Okay. Updates. What about physics? What is to cover for physics?
Physics.
Hmm.
The is it the light? Then got reflection and refraction.
Reflection, refraction. Then after that, okay. How are you coping with the chapter?
Why suddenly got math inside one?
Hey, but it's physics, bro. Physics always got a bit of math inside, right? No?
This is too much. This one got a sine I over sine R something. My.
So basically, it's like, bro, I didn't sign up for this. Why got trigonometry in this thing? Is it?
Why sine so hard?
Okay. There's good news, bad news. Yes, there's sine inside. There's out of sine, cosine, tangent, there's only sine inside. It's called Snell's law. But the good news is, you don't have to know trigonometry to do that.
Yeah.
Yeah. Okay. So. Okay, you pick. We do a bit of physics crash course, or you want to try more questions for QA. Pick one.
Physics.
Okay. Okay. So under this, right? Okay. So physics, you mentioned about light. Okay. Light primarily has reflection. Reflection very straightforward. It's basically like a surface. Then the lights go boing and bounce off. Then you has refraction. Refraction then is a bit different because like on top this one is like air, this side on top is water. Suddenly you are moving from a one dimension to another dimension kind of thing. Like normally it's like one medium to the other medium. So because light normally travels in a straight line, right? But when it travels from air into water, it gets bent. Why? Because the speed of light traveling in air versus water is very different. So rather than going in straight line, the light gets bent. So that's refraction. Under refraction, there's something called refraction index. What's refraction index?
The N.
But what are the formulas related to N? Any idea?
N equals speed of light over speed of medium.
Okay, very good. What is speed of light? The number.
3.0 times 10 to the power of 8.
Very good. Meters per second. So this is basically the speed of medium. So basically, so in this case, can you understand that if n equals to 1, it means that it's traveling at the speed of light. Why? Because n equals to c over v ma. If c is 3 times 10 to the power of 8, in order to equals to 1, the bottom must also be 3 times 10 to the power of 8. Then you cancel equals to 1. So when n equals to 1, it means the object is traveling fast at the speed of light. Make sense?
Yes.
So now if I have my, okay, can anything travel faster than the speed of light? Answer is no. It was said that if you can travel faster than the speed of light, we might have a time travel ability. If you travel faster than the speed of light, you might actually go back in time. So speed of light of 3 times 10 to the power 8 will never, you will never have, we barely can even match it, because we can't, human have not have the technology to travel at the speed of light yet. So that means V will always be a smaller number than on top. Then as the number here becomes smaller, n will be bigger. So n will always be larger than 1. Because when n equals to 1, you travel at speed of light. So this divide by a smaller number, n will always be bigger than 1. The bigger the reflective index, the bigger the refraction index, the smaller the speed actually travels. So, so this is your first equation and you need to be familiar. Then you have a second, okay, then since we are talking about refraction, might as well we talk about this. Okay, then we have this is air to water. This is water to air. So in this case, light travels. Then this is called the normal line, which is 90 degrees to the thing. So this is called normal. And then you do this. The angle is always measured from the solid line to the dotted line, between the normal and the light ray. This is I, this is R. Same thing, light ray travels, dot, 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 dot. This is air, and like that. This is I, this is R. So in this case, do you know how to tell whether it bends towards or bends away, or you just merely use memorization only?
If it's denser than air, it bounce inside.
Okay. Let me try to explain this. Try to understand this. Okay. In this case, we have, you know what is called optical density?
No.
Okay, optical means anything related to light, how light can pass through. Density means how packed, I guess. Okay, so now I give you two scenarios. First scenario, you know, it's like the MRT platform. Here the MRT runs here and here. So there is Xiaoming. Xiaoming wants to Naruto run on the platform. In the first scenario, the entire platform was empty. In the second scenario, the platform got some people. In which situation, in A or B, can Xiaoming run faster? Is it the one with empty platform, no people, then can run faster, right?
Yes.
So in this case, then this one Xiaoming has sorry, zoom. Then he has to avoid the people, it will be slower.
Yeah.
So you can imagine the same thing. Imagine Xiaoming is like the light, and light, when it passes through an object, if it allows it to pass through very easily, it will be faster. And we call this optical less dense. Means less things are blocking it. When there are things that it blocks it, blah, then the light will pass through will be slower. This will be optically denser. Okay?
Yes.
So, when something is optically less dense, you travel slower. So you can imagine when something travels slower, the angle to normal will become smaller also. Whereas if something is less dense will be faster. The angle will be bigger. Because less dense means less thing blocking it, right? Then it will be faster. Then the angle represents faster means it's going to be bigger. If the optically density is more dense, that means a lot of things blocking it, it will be slower. Then the angle will be smaller. Okay? So in this case, you see, water, slower, so angle also smaller. Then air, faster, angle also bigger. Make sense? Okay, all good? Okay. So just there are official ways of actually remembering Snell's law and stuff. For O levels, there's a shortcut for it, so I'm gonna teach you. In this case, will be n equals to sine I over sine R. But sometimes the teacher will tell you that it's n equals to sine R over sine I, right? Did the teacher tells you how to remember which to use?
If it's from something else to air, then it's the sine R over sine I.
Okay, I tell you what it is. If it's sine I over sine R, it means that it should be, this is I, this is R. It should be from less dense to more dense. If it's R to I, it should be if it's from I to R, then it's less dense to more dense. If it's R to I, it is from more dense to less dense. This method to remember is rubbish because it's very easily you make mistake. You just have to remember one thing. Whichever big put on top. What do I mean? You see, compare I and R. I is bigger, right? There you go. So I put on top. Compare I and R. R is bigger, right? Then R put on top. Then 你就不用去 memorize it. All you need to ask is if it's I bigger than R. Let's say I is 30 degrees. R is like 25 degrees. Then your answer will be sine 30 over sine 25. If compare I and R, I is 50 degrees. Then R is like 65 degrees. Then you just take the R and put on top. It becomes sine 65 over sine 50. Then this will become 1,000 times easier. Then no need memorize already. Any angle bigger, put on top. You'll be good. Okay? Okay, let's try some questions since while it's still fresh. Have school started on total internal reflection?
Yes, today.
What? Bro, it's only 1 week. Why your school zoom?
I also don't know. A lot of people don't understand what's going on.
Okay. Let's cover refraction first. Then, we need to spend some time on total internal reflection also. Your school on Zoomies, just run super fast.
Yeah.
If the class say don't understand, then teacher just continue teaching.
Yeah.
Huh? But no one got anyone got guts enough to, we don't understand.
The misbehaved people.
Huh? They will make noise, then the teacher will scold them.
Yeah.
Oh no.
won't listen, then they'll sleep in classes.
Hey, if something like this happened, tell me, then I'll explain to you. Anything the school didn't explain well, let me know so I can explain better for you, okay?
Okay.
Okay, try this question. Grab a calculator if you need, because you need to do your sign. So what's the angle of incidence?
90 minus 30. Incidence 60 degree.
Then what is your refraction? Angle of refraction?
35 degree.
So what would be a refractive index?
Sine 60 over sine 35.
Then I get 1.51.
Yes.
Okay. A lot easy, right?
Yes.
You know why I like science? Because I can always find ways to. There are things that it's not in math. You have to practice so much. Your skill don't practice, will disappear. Science, or once you found some technique or some way to understand, and then you found some shortcut to remember, so your brain will absorb it. It's a easy to score thing. The problem lies in how do you find that first way to easy remember it. So yeah. Okay, try this one. This one a bit more layers.
A is 65.7 degrees.
Wonderful. Good job. 65.7 degrees. Then the speed of light in medium y. Since we know that the medium is 1.48, speed of light is 3 times 10 power 8. So so big. 1, 2, 3, 4, 5, 6, 7, 8. Okay.
Two 2.02 times 10 to the power 8.
Yeah, good job. Okay.
Is it 2.03? Because there's a 7.
Okay, you can put 2.03 times 10 to the power 8. Right.
Okay.
Okay. A bit more. So this one different again.
B.
This one will be a sine. Sine 50 divide sine 39. And you should get 1.58. C.
Yes.
是不是变简单 become way easier? Right? You don't have memorized the stupid thing already. Okay, so the next thing what we need to focus on will be how much do you understand about total internal reflection?
Nothing.
Okay, where is current school started or already finished?
I don't know. They started with the drawing also. So
What do you mean by drawing? As in the
you draw from the how the eye see the object, and then like you draw the angle or the angle.